All right, so for test 9, we're going over unit 9, which we just did, but also unit 1, 2, and 3 from last semester. So unit 1 was just basic algebra. You have one-step problems, which are problems that just require one step to finish. So you set it up just like this. Let's say, I don't know, like 15. So split them up, you do inverse operations. So this is plus 2, you need the x by itself. So you minus 2 minus 2, that's going to be x equals 16. You also have two-step problems. So that's going to be like 2x minus 10 equals 40. So to do the opposite here, plus 10, you get 2x equals 50. So that was your first step here. Your second step is to divide by 2, and you get x equals 25. You may also see this with distribution. So let's say like 3x minus 4 equals, let's say 120. So you distribute this. So 3x minus 12 equals 120. Add 12, 3x equals 132. Why did I pick such a big number? I'm not sure. So answer is x equals 44. So this is first part. One-step equations, multi-step equations, and using the distributive property as well. So with one step, I mean, the definitions are really just self-explanatory, really. Okay, so that's unit 1. Unit 2 is linear functions. So there's some things you need to know. Okay, so there's some formulas. Slope. Slope is the rate of change. That's important to know. Slope formula. The next three are formulas. Let's do this. The slope formula. It's n equals y2 minus y1 divided by x2 minus x1. That's slope. You have forms of an equation. There's slope-intercept form, which is y equals mx plus b. And its slope. B is the y-intercept. And then you also have point slope form. Point slope, which is y minus y1 equals mx minus x1. M is the slope, and then x1, y1 is a point. Any point on this line will work for that one. Okay, so determine something is a function. So if something is a function, if something is a function, it will pass the vertical line test. Vertical line test. Man, that doesn't look very nice. I'm gonna write this more carefully. Vertical line test. So what that looks like, you have, let's say you have some function here. Let's do this. So you have this graph. Okay, so anywhere you draw a vertical line here, it's good. Draw a vertical line here, it's not good. You have this point here, you can't hit more than one point. So this one passes the vertical line test, this one fails the vertical line test. Okay, so continuity, domain, and range. Let's see. So continuity, it's either continuous or discrete. So continuous, this is where the second line, discrete is where it's points. Domain and range. Domain is the x values. And then range is y values. Remember that the brackets mean you include it. Open circle, infinity. And this is where you include it. Close circle. Line. This also applies when you have asymptotes. We didn't talk much about that, so but this is just for your reference. Yeah, so that's this next section. Operations on linear functions. Let's take this one. Let's go over here. So function notation. All right. Function notation is so like you have some sort of something or other here. Let's just throw a couple down. Let's say f of x equals, I don't know, 5x plus 10. And let's say g of x equals let's say it's 1/2 x minus 4. So the first part is function notation. So for function notation, you'll have something like f of 5, and you'll evaluate that. So f of 5. Oh, okay. So what you do to start out here, you f of blank equals 5 of blank plus 10. Actually, I'm going to change this number. I'm going to use that same number. Let's do f of 6. So whatever that number is, it comes down here. So f of 6, 5 times 6. So f of 6. Oh, wait, you know what? I'm going to leave that blank so you can see the step after I've done this. So f of 5 of plus 10. Yeah, and so what you substitute in is the 6 here. So that's going to be f of 6 equals 5 times 6 is 30 plus 10. So f of 6 equals 40. So this is evaluating functions, which is also called function notation. You can, like if it said g of some number, you plug it into g. Okay, what's next? Adding, subtracting, multiplying, dividing. Okay, when you have adding and subtracting, so let's say you have, so this is the next evolution of what we did in the green one here. Let's say you have f of 1 plus g of g of 10. No, g of 12. So f of 1, that's going to be the one on the right. F of 1 is, what am I doing? Here, let's do it this way actually. I'm going to do f of 1 equals 5 times 1 plus 10. So f of 1 equals 15. I'm going to do g of 12 equals 1/2 times 12 minus 4. So that's going to be 6 minus 4, which is 2. Okay, so that's what I use here. This f of 1 is 15, so 15 here. G of 12 is 2, so 2 here. So f of 1 plus g of 12 is 2. You do similar thing when you do subtracting. Yeah, might as well show an example of that. If you get it and you're watching this video, you can skip over this next part, but I'm going to do one that's subtracting. So let's try about f of 2 minus g of 6. Yeah, let's do g of 6. So let's break this down a little bit. I'll show this one a little bit differently. So let's do f of 2 equals 5 times 2. 5 times 2 plus 10. And then g of 6. G of 6 equals 1/2 times 6 minus 4. So this one is going to be 10. This is going to be 20. I'm not going to skip this step actually. So 10 plus 10, which is 20. Wow. And then over here you'll have 3 minus 4, which is -1. So if we did that, remember it's subtracting. So it's 20 minus -1. So it's actually be 20 plus 1. Negative, negative, make it positive. So the answer is 21. So what I did was I just did this part in the middle here. You can also do this with multiplying and dividing. Multiplying, dividing, and then parent functions will be the next thing here. Look how long this video is. Like I've been doing this for a while. It's a lot of stuff. So with multiplying, dividing, let's see, let's go black. So let's say you have 2 times f of -2. No, -3. So it's the same thing. You do 2 times, let's do this. F of -3 equals 5 times -3 plus 10. So that's going to be -15 plus 10, which is -5. Okay, so this is -5. So the answer is -10. Works the same for dividing. You do the steps and then you have it multiplied by the fraction or whatever. Okay, parent functions. You know, I need to add stuff for transformations. I don't have that on your thing, which, no, I think that comes later. Yeah, that comes later. Okay, so for parent functions, let's say you have a line like this. Let's do one like this. And let's do one like this. So parent function for this is a linear function. So linear function, the parent function looks like this. Quadratic looks like this. And then exponential looks like this. So even though it's shifted, looks a little bit different, these are transformed. And then these are the parent functions. So you take the parent functions, you apply shifts, vertical and horizontal shifts, and you can also do stretches and shrinks to get the transformations. Okay, that one was the meteor section. Okay, roots and logarithms. So even a square root function. I think there's something. No, yeah, there's something missing here. So the square root function, this is the square root function. This is the cube root function. Find this is the square root. This is the cube root. The opposite of square rooting, if you do this squared, it just becomes x. So over here, if you do cube root of x cubed, it'll just become x. So there's some questions where you have to solve these. Let's do one of those. So let's say you have square root of x minus 2 plus 15 equals 20.
Good morning, teachers and students. Please pardon this brief interruption.
So do minus 15, minus 15. You have x minus 2 equals 5. Then you square both sides. So you square this, and you square this. Then it's going to be x minus 2 equals 25. Add 2, you get x equals 27. So that's how this works when you solve. What else? Changing form of logarithms. Okay, so there's a formula. Log base b of y equals x. Which will be the same thing as b to the x equals y. So this is important. This is how you do the change of base stuff. So let's say you have log of, I don't know, it really doesn't matter. Log of 7 of 20 equals, like, I don't know, g something. So here's your red one. Here is your blue one. And here is your green one. Hey, G for green, that worked out. So the red one is 7. 7 to the green one to G equals 20. So this is rearranging the logarithm. So you can do that backwards, you can do that forwards. And then you have the last thing is power, quotient, and product property. So some more formulas for you. Let's do the red. Log of m times n equals log of m plus log of n. When you divide, that's going to be log of n minus log of n. And then when you have exponents, log of n to the n, it's going to be the same thing as n log n. So those are the formulas. So an example of that, let's say you have log of 7 squared times m. Let's say this is to the third here. Okay, so first step, you have to deal with that exponent. So this is actually going to be 7 to the 6th, and if this is m to the 1, that's going to be m to the 3rd. So now you can do the product rule. Log of 7 to the 6th plus, I'm going to do that off to the side instead of here. Log of 7 to the 6th plus log of m to the 3. Then you can do the power rule. So it's 6 log 7 plus 3 log n. And that is everything. Real quick, all the definitions. Basic algebra. One-step equations require one step to solve. Multi-step require multiple. When you distribute, whatever is outside the parentheses goes to the inside. Slope is the rate of change. Slope formula is there in black. Slope, intercept, and point slope are there in blue. Determine something's functions, vertical line test. Continuity of the function is either discrete or continuous. Discrete is if there's breaks in it or dots, or like if there's a space. Continuous is if you can use your pen and draw this and don't have to pick up your pen, then that's continuous. Domain is where the function exists on the x-axis. Range is the y-axis. Function notation is just substituting a number in for the variable. Adding, subtracting, you do function notation and then you add the two answers. Multiplying, dividing, you do function notation and then you multiply or divide that number by whatever you need to. Parent functions, you take the transform function and you put it back to the original or vice versa. Roots and logarithms, opposite of square root is squaring. And then if you need to, oh yeah, domain and range. So the domain of a square root, I'll talk about that in a sec. Domain of a square root is from the point where it exists all the way to the end. And then cube root is all real numbers. Changing form, use the formula, product, quotient, power property is also formulas. Last thing in this video, for square root, the domain starts at the dot and it goes that way. So x is greater than or equal to the x value of dot. And then y is greater than or equal to the y value. That's domain, that's range. The only exception is if it's like this way. Yeah, so this is when it goes up and to the right. If it goes down and to the left, you switch these signs here. Okay, that covers everything.